In this quick tutorial, we will be looking at how to recreate images using processing that are visually similar to these ones. These are posters made for the B3 Biennale des bewegten Bildes in 2013. Let's take a look at this particular poster and try to understand what's going on. For that purpose, I will just briefly switch to Photoshop. And this is the image that I've placed in Photoshop. If we take a look at the blue channel, we can see it's made up of concentric circles that oscillate between white and black, and they gradually expand and become larger and larger from the center of the poster. You can see some ghosting of some effects appearing here, and if we take a look at the green channel, we can see this is what is going on, only more amplified and more easy to see. These circular bands of color are given a spiky effect and making them look very pointy towards the center. And this effect is also utilized in the red channel. We can see indeed here the spikes have become more pronounced and more in number. So adding these three layers, red, green and blue, to make this composite image, we can see that this is actually how it's done. I have just taken what I believe was the red channel, and in Photoshop I've pasted it in so that the center here of the shape is also the center of the canvas, and then using this filter that translate Cartesian coordinates to polar coordinates, we can sort of unwrap this image and see this effect in sort of like a Cartesian plane. So this is what we're striving to make. I don't know if this makes it easier to understand, but bands of white and black gradually oscillating, becoming thicker and thicker towards the bottom. And then we add these spiky effects, really pronounced towards the bottom of the image, and then gradually decreasing towards the top. Now, let's try and switch to processing to actually get some code done. First up, let's write a quick basic template. I will make the size of my output window fit my screen and keep the same aspect ratio as the original poster. Next, I will make sure that I utilize all the pixels available on my screen. This may vary depending on your type of screen. If you've got retina screens or high density screens, why not utilize all the pixels? Next up, I will just set up a basic double for loop to loop through every X and every Y on the image. The reason I'm using pixel width and pixel height has to do with this line of code up here. Now, to see that this double for loop is indeed working, let's just try to fill each of the pixels on the output window with the color red. Yes, indeed, we have a red color. So far, so good. What we want to do now is to take what we've got here, a set of X and Y coordinates, and translate that into polar coordinates. Let's just write some code to that and I'll discuss what's going on. Okay, so in this code that I've just written, we take the X value from the double for loop and add it in here to this map function. It is mapping all of the X coordinates from 0 up to pixel width to the range -1 to 1. Same thing goes with the Y values, just on the height. To figure out how far we are from the center of the screen, we take the square root of xval squared and yval squared. And to figure out the angle, we use the a tan2 function and just pass in yval and the xval. That way, we translate from the Cartesian plane with an X and a Y, specifying the position of our pixel, and calculate the corresponding radius and the angle in polar coordinates. Now to see this effect, if we're getting somewhat closer to what we saw in Photoshop, let's just try to calculate a temporary color, a grayscale value between 0 and 255, based on the sine value of the radius. Let me just type some code here. Now, what is going on here? Well, first of all, I'm using a sine function, and I'm taking the radius as a parameter. And radius is initially 0, and then it's gradually expanding as we move away from the center. Now, it's a very small value still, so I'm just multiplying this with 100 to get some more visual results. We all know that sine is returning values in the range of -1 to 1. So here I'm just adding 1 to this so that I'm in the range of 0 to 2. And then I'm multiplying that by 128 to convert this range of 0 to 2 into a range that extends from 0 to 256. So I'm getting a number here of a sine value, and then I'm passing that as a color, putting it into temp, and then setting the pixel. And we can see, if I'm just for a moment here stopping the sketch, saving it and running it in tweak mode, as I change this parameter here, we can see we're moving closer and closer. The concentric circles are getting more dense as I'm increasing the number, and we can play and fiddle around with this. Now, okay, so this is somewhat working. There's just one main problem with this. Right now, the aspect ratio is all skewed. We can see that if I'm running my sketch, it's almost like squished horizontally. So on the original artwork, we had perfect circles, not squashed ellipses. To fix this, I will add 2 global float variables. These variables I will refer to as the width ratio and the height ratio. We need to calculate those, and we can do that here in Setup. Let's just take a moment to understand what's going on here. I'm using the min function, and that is given 2 values, and it's returning the smallest one of them. Dividing the width of the canvas with the height of the canvas, and in case this turns out to be an aspect ratio that is larger than 1, then it's just going to return 1. The same thing goes on for the height ratio. I'm dividing the height with the width, and similarly, if it's returning an aspect ratio greater than 1, it's just going to give us 1. Ultimately, this means that we will have a width ratio and a height ratio. One of them is going to be 1, and the other one is going to be less than 1, depending on the dimensions of the output canvas. So now down here, where we had our X value and we had specified this range from -1 to 1, I will just pass in the width ratio, the negative width ratio, and the positive width ratio, and the same thing down here, negative H ratio and a positive H ratio. So let's take a look at our sketch now. Much better. Circles, concentric, emanating from the center of the image, and we can change that by tweaking this value down here. So far, so good. Now, before we move on, I just want to make sure that I briefly mention this article on Mathematica, because it is the one that got me on track as to how to solve the math and how to use the different functions, some sine waves, some logarithmic functions that I will show you. So if you're more interested in a more in-depth look at the math behind images like these, I will make sure that I link to this article in the video's description. Currently, the color for each pixel is now being calculated here in this temp variable, and as the name implies, well, this is only temporary, so I will just get rid of this now. What I would much prefer is that we have a function of our own. I'll just label it calc val, and have that return a value to us. Now, this calculate value need to take in some input and then give us an output. And well, first of all, it's going to take as an input our radius, and it's going to take our angle. Let's just set up this function down here. As you might have noticed, in addition to radius and angle, I have added 3 other parameters, namely angle multiply, POW, power, and amplify. What they do will hopefully become visible once we start rendering some output to the screen. But I need to make sure for this to work that I add these parameters up here where we are calling our calc val. So for now, briefly, I will add a few numbers and we can tweak these and understand what they're doing. Now we have the right number of parameters. They have some values. Some of them are calculated up here, the radius and angle, and some of them are hard-coded here, but they can be fiddled with using the tweak mode. Down here in our calc val, this is where the magic will happen. Now I need to calculate this sine value that we had before. And something needs to go in here, obviously, but it's quite a long formula, so I'm just going to break it up on a few lines. First of all, I will be taking the log value of radius. Next step, I will be taking the absolute value of a sine function that takes the angle and multiplies it by the angle multiplier. The absolute value of that sine, and raising that to the power of what we had specified as our 4th parameter. Let me just write that out for you. The last remaining thing is to, well, just amplify the entire thing. When we're working with these sine numbers, we tend to get numbers in a very small range. But by just multiplying what we've got now by a number, and that is the last and 5th parameter we have in our calc val function, we can amplify the entire thing. Okay, so our scene function, and I'll just relabel that to scene val. Our scene function is now complete, and the thing is, we need to return something here. I can't have this calc val be a void. As we're using it up here, we need to pass this result of this calculation back into the variable gray. We need to do that by making it return a float, and as long as we return a float, we need to have this return keyword in here. What we need to return isn't just scene val, because as we can see, it's the result of a sine function. So it'll always be in the small range of -1 to 1. We need to map that out to something else. So I'm just going to use this map function. What do I need to map? I need to map my scene val. It's always in a range of -1 to 1, and I will just be remapping that to 0 to 255. Fingers crossed. This will, before I run it, I need to exchange this temp to this gray. Okay, let's give it a test. As we can see now, we have got an image that is almost similar to what we saw in the red and the green channel of the original artwork. And as I've run this in tweak mode, we can now fiddle with the parameters and see exactly what is going on. As I increase this one, the angle multiplier, we can see that we're getting more and more divisions. And the next one that I've got here, the POW, as I'm making this smaller and smaller, decreasing that, we can see the spikes are almost disappearing. And I can just crank this up here and have them be really spiky. And of course the amplify, I can just, by cranking this one up, have the concentric circles be more closer to each other. Now, we're getting some output here. It's complaining that the map is sometimes given this NaN, not a number. And obviously, if what you're being given is not a number, then you can remap it. So let's just quickly put in some error prevention and some prepping of this calcval function. So I just wrote 3 lines here. The first one is always going to keep radius to a minimum of 0.01 because obviously we can't do log 0. And that's what's going on down here. And when the radius is 0, we're giving this not a number. So we just make sure that the radius is always going to be at least or no smaller than 0.01. The next one, the radius here, we're just taking and multiplying this by the minimum of either the width ratio and the height ratio. And that is to make sure that this spiky effect caused by the power part of our equation is always going to be visible even in the corners of the sketch. It's a minor detail, but again, let's just fix that. And then the last line is to ensure that when using this power function, that we will always make sure that first of all it's going to be positive. That's using the absolute value, and that's going to keep the spikes pointing inward. I believe the spikes were pointing outward on some of the other specimens we saw from the original poster, but never mind. I'm just wrapping this in absolute to keep the spikes going inward, and I'm going to make sure that they are always going to be at least 0.05. Again, if this value is going to be too low, it's going to cause some pretty ugly artifacts in the rendering. So a bit of prepping and a bit of error prevention. Now we've got this calcval function complete. So up here, let's try now to extend this use of our calcval function from just rendering gray to actually rendering red, green, and blue. So that was a quick fix. Just multiplied that 3 times. And now we have our R and G and B for the red and the green and the blue. And as we can see, these can be changed individually, which you will see when I run this sketch in tweak mode. Right now it's appearing to be green, but if I'm changing some of these, we can see all of a sudden color will appear, and I can fiddle with some of these settings, and magically we will have color appearing. We're getting pretty close to rendering the original artwork. It's just a matter of fine-tuning and dialing in all of these variables that we have in our calcval function, and we can achieve a lot of different outputs. But let's try to take it a step further, and instead of just tweaking these manually, why don't we see if we can have some of these posters be generated automatically for us? For that purpose, I will introduce a new function that I will label make random. I will just comment out this bit because it might come in handy later if we want to do some manual tweaking. But for now, I want to be able to go like this. Ultimately, this is what I want. I want the R and the G and the B to be generated randomly. I still need to pass the radius and the angle to my function because the radius and the angle, as we can see here, are both calculated in this double for loop, so we need to pass them on to our function. Let me just quickly write up that function. Now, if we take a look at this function, it's being passed the radius and the angle, and we still need to calculate the 3 remaining parameters: angle multiply, POW, and amplify. Now, instead of having these being specified as we're doing up here as hard-coded values, instead they're being assigned a random number. In case of the angle multiplier, we need that to be an integer, but the pow and the amplify, those can both be floats. So here I'm just generating by random and passing it into this calc value that we made up here, along with the radius and the angle. So all 5 parameters, and then returning that from the make random. So up here now, this should work. Ouch, not what we had hoped for. This is just a garbled mess of RGB colors flickering before our eyes. So obviously something's wrong here, we need to fix that. The quick fix is to simply just add a random seed and then just pass it in a number. I'll just type something arbitrary here. And if we take a look at this now, we can see that, okay, this particular number, 8,876, will give us this result. So the code seems to be working, but if I want to iterate through these, I can either do this, run the entire thing in tweak mode, and just use tweak mode to select a few other. And as we can see, they all look different. So already we've got some fancy, nice output, but I believe they are too RGB-ish to my taste and to my liking. Can get lucky and have some of them be subdued, some of them are quite vivid, some of them are mainly, I don't know, bluish, purplish, but I would like to be able to control this even more. So what I'm suggesting is that we kind of improve the calcval function. So let me just add some more code. Here I'm editing the calcval function and I'm adding this integer base, sort of like a base color, a base value, and then a spread amount. How far can the values deviate from this base number? Say if I specify base as 128, it's going to give me a middle grayish hue, and I specify the spread as 10. Well, it'll allow me to just render a result of this calculation as hues within the range of 118 to 138. So I can kind of specify how much, how less I want of the gray and how far it can spread. So let me just implement that in the make random function as well. Now obviously these values, play around with them and see if they produce results that you find pleasing. Just for the sake of completion, and if you want to use these later that we've just commented out, I will just be adding these additional 2 parameters to both of them to make sure that they will work later on as well. If we look at this random, make random, these 3 we've already discussed. Now here, in addition to choosing the angle multiplier, the amplifier and the power, we're also using random to choose the base number and how far it can spread from the base number. So let's take a look at it now. Oh yeah, forgot to add them to this calcval function. I'll just do that. Still getting some of these RGB traces, but some of the other ones I believe are more well, still colorful. Yep. That would be a matter of dialing in these 2 down here. Perhaps I could just lower the amount of spread and try to calculate a new one. Yeah. This is for you to play with. Now I just want to add the ability to quickly flip through each of these different renderings and do that by just tapping a key instead of using tweak mode. To help me do that, I will replace this hard-coded value with a variable named seed. And I will just add this up here. So now, as we can see, we are getting the result of a seed, a random seed of 0. And if I change this to say 10, now we will get the specimen associated with the random number sequence of 10. What we've been doing so far is to just every draw loop painstakingly go through each pixel on the output canvas, and that is quite CPU intensive. So I suggest that we just now add this no loop and just have the draw loop be triggered whenever we hit a key. I'll just write the key pressed function. I'm using the key code, at least to the two of them, the two first ones, to detect if the up arrow key is pressed on the keyboard or the down arrow key. If we're pressing the up arrow key, we'll just increment seed by 1, and similarly, if we press the down arrow key, we'll just decrement it by 1. Now, if I just press the up key, nothing's gonna happen, and that's because I'm stupid. I need to just add this redraw because we just enabled no loop. Sorry. So now if I'm pressing the up key, we can see that I'm now getting random seed number 1, 2, 3, and so forth. So I can just go on. If I want to press the down arrow key, we can see I'm now getting number 2, number 1, 0, and then, okay, it's flipping around and actually choosing a number less than 0. Oh, so apparently random seed can handle negative numbers. I was about to go through hoops to build in some sort of fancy mechanism here to prevent that, but okay, we'll just leave it as is. Now we just need to give ourselves the ability to save what we've got on our output canvas. So for that purpose, I will just briefly whip up a file name. This will produce a file name that is unique, and we will capture the seed number used to generate that particular image. That is quite handy if we want to recreate that later on, say in a larger resolution or so. So here, using save frame to actually save the output of our canvas and then give us a little confirmation in the console that it has been saved as, and then the file name, sorry. And as we can see now, I can go through all of these, and whenever I feel like something is pleasing to me, nope, this might be working. I can just press the spacebar, and as we can see down here, saved as pattern number 8. And if we just go ahead and check our sketch folder, we can see that, yes, in addition to our PDE with the source code, we have now got a PNG image of the pattern seed number 8, and I can preview that, and it looks great. One last thing that I want to just quickly fix is this one up here. This is giving us the same number from the beginning. Whenever we run the sketch, we will always be given seed number 0. Here we are assigning the seed variable a random number from 0 to the maximum integer possible. Let's test this out. Quickly going through some of the examples produced. This one is nice, and I'll just press spacebar. And we can see indeed we've got a very large seed number. One final thing, promise. We need to add, for the sake of completeness, an overlay of typography that I've just lifted from the original poster. And it looks like this. This is essentially just a transparent PNG with some lettering and some shapes up here in the top of the image. I just need to import that and overlay on top of what we've rendered. This is my file, typography.png, and I will just drag that onto the processing sketch, and it confirms that one file has been added to the sketch. Now we just need to add a container for that, and we need to load it. And finally, we need to place it. Let's test it. There we go. So I hope that you have enjoyed following along this quick tutorial and that you find great use for the code. Really, this is just a basic scaffold. You can play along with formulas. You can play along with the colors, the way you assign colors. Essentially, I just urge you to just not take this one-to-one, but instead, now that I've given you an explanation of the underlying principles, try to make it your own, try to improve it, try to use it in some different ways. And of course, feel free to use it whatever you want to use it for. Thank you for watching.